What if we were wrong about what's moving through our solar system? What if the object NASA first labelled 3I Atlas isn't a comet at all, but something far older, far colder, and far more deliberate? When scientists first tracked it, they said it was routine. A small interstellar visitor following the faint and fading trail of objects like Oumuamua and Borisov, relics from beyond the sun's domain. But that was before the images came in, before NASA realized what Atlas truly looked like, and why its shape defied every model they had ever run. The observation that changed everything. It began, as many discoveries do, with a glitch. A single blurred sequence from the Hubble archive, recorded in late 2024, showing 3I Atlas just as it crossed the orbit of Mars. At first, the data seemed corrupted, streaks, distortion, lens flare. But when engineers processed the frame-by-frame feed, something emerged beneath the static. Atlas wasn't smooth like a comet. It wasn't tumbling through space the way ice and rock usually do. It was structured. You could see repeating lines, geometric shadows, a faint symmetry like the ribs of some colossal ship. At first, researchers thought it was an illusion caused by cosmic rays hitting the sensor, but then two other telescopes, the James Webb and the European Extremely Large Telescope, confirmed it. Same pattern, same shadowed ridges, same unnatural glow. That's when one of the analysts, a quiet astrophysicist at NASA's Goddard Center, whispered something that would never appear in any official transcript. This thing doesn't look natural. The motion. That made no sense. For weeks, astronomers tracked Atlas as it slingshotted past Mars. Its orbit should have been simple, a graceful curve toward the outer system, a slow fade into the void. But that didn't happen. Instead, 3I Atlas made a correction. A small but measurable change in trajectory. Not from gravity, not from sunlight, and not from jets of vapor, but as if the object had decided to move differently. At first, the change was dismissed as a data error, but every instrument, from NASA's Deep Space Network to Japan's Subaru telescope, recorded the same anomaly, a maneuver, a burn, if you will, from something that should not be capable of propulsion. And here's the strangest part. That course adjustment pointed Atlas directly toward Mars. The Mars anomaly. By the time Atlas approached the red planet, every major observatory on Earth was awake. Harvard astrophysicists coordinated with NASA's Jet Propulsion Lab and the ESA Mars orbiters to capture high-definition spectral readings. They expected ice, maybe rock, maybe volatile gases. What they found instead silenced the room. Atlas was emitting a narrow beam of energy in the ultraviolet spectrum. Not random, not natural. The frequency oscillated at precise mathematical intervals, 314 megahertz. Pi, a constant that doesn't occur in nature without cause. One physicist joked that it was like the universe winking at us, but no one laughed. Within hours, the beam flickered and vanished, and where it had struck the Martian surface, near the Elysium region, orbiters picked up a faint circular disturbance in the dust. Perfectly smooth, almost polished, a crater that wasn't there a day before. NASA released no public statement. Harvard issued a short press note about spectral interference, and yet in internal memos leaked weeks later, the phrase appeared again and again, artificial coherence detected. The hidden signature. When Atlas continued past Mars, something strange followed it. Not debris, data. All around its wake, instruments began to pick up a pattern in the background radiation, faint ripples in the cosmic microwave field, spaced evenly like the beat of a slow drum. Some called it an artifact of measurement. Others said it looked eerily similar to what SETI researchers once described as engine harmonics, vibrations that could indicate directed propulsion. In one confidential NASA report later obtained by the Astronomical Review, the author wrote, "If these harmonics are genuine, Atlas may not simply be reflecting sunlight, it may be broadcasting. Broadcasting what? No one knows. But deep space radio networks began recording whispers of frequencies just beyond the hydrogen line, the same range scientists have always said we should monitor for intelligent signals. Coincidence or communication? The shape that shouldn't exist. Then came the newest image, the one that shocked even veteran astronomers, captured by the Webb telescope in infrared. Not a blurry streak, but a full, crisp profile of the interstellar object. And it wasn't spherical. It wasn't even irregular. It was long, impossibly long, with parallel lines running its length, like an ancient structure weathered by cosmic dust. Some estimated its size at 60 kilometers, hollow in the center, glowing faintly from within. NASA analysts said the glow was likely due to sublimating ices, but an anonymous engineer from the European Space Agency disagreed, saying the internal heat signature was too even, like something maintaining a constant internal temperature. That detail didn't make it into the official release, but when the image leaked online, you could feel the collective chill across the scientific community. Because that shape, long, symmetrical and hollow, matched the early radar returns of Oumuamua, the first interstellar visitor ever detected. Two objects, years apart, sharing the same impossible geometry. The fracture theory. Harvard astronomer Avi Loeb once suggested that Oumuamua might have been a fragment of alien technology, a light sail or probe drifting through interstellar space. That idea was dismissed, ridiculed even. But now, with Atlas, the conversation has changed. In a leaked audio clip from a recent NASA briefing, you can hear a senior astrophysicist say, "If Atlas is part of a larger structure, a network or remnant, we're not observing an object, we're observing a process." What kind of process? That's the question no one wants to answer. Some think Atlas could be gathering data, scanning planetary magnetic fields as it passes by, a cosmic census of a life-bearing worlds. Others fear it could be something more active, a trigger or a probe preparing the way for something behind it. Either way, its approach toward Mars might not be random. It might be testing something: the planet's thin atmosphere, its radiation belt, its potential as a transmitter. The red signal. In mid-2025, a faint red pulse was detected by the MAVEN orbiter. It came from the direction of 3I Atlas, lasting only 9 seconds. When the signal was enhanced, the waveform revealed a pattern: 3 sharp peaks followed by 1 long decay. 3I Atlas. Coincidence again? Perhaps. But within hours, several Mars rovers briefly entered safe mode, their systems overloaded by unexpected electromagnetic interference. And when engineers examined the data logs, they found something deeply unsettling. The timestamp of the interference matched the pulse exactly. NASA never confirmed the link, but internally, one researcher wrote a note that simply read, "Atlas acknowledged Mars." The silence that followed. Since that pulse, 3I Atlas has gone quiet. It's drifting now, heading toward the outer system, leaving behind only questions and a trail of strange echoes in the deep space network. But here's the thing: every 27 hours, telescopes still pick up a rhythmic flash from its trailing edge. Dim, predictable, and mathematical, as if counting. Counting what? No one knows. Some think it's decaying, others think it's waiting. And maybe, just maybe, it's listening. The unsettling question. So what makes Atlas terrifying isn't what it's done, but what it's preparing for. Because every pattern, every movement, every emission suggests a logic, a sequence. It behaves not like a fragment of rock, but like a probe running through stages of a program. And if that's true, the final stage might not involve Mars at all. It might involve us. As it drifts beyond the orbit of Jupiter, Atlas occasionally sends back glints of light, tiny flashes that align with Earth's position in the solar plane. Statistically meaningless, NASA says, but they happen every time we turn our largest radio telescopes its way, almost like a response. So when NASA says Atlas looks more terrifying than expected, they're not talking about fear in the human sense, they're talking about recognition. Because for the first time, they're looking at something that might be looking back. And so, as 3I Atlas drifts into the dark beyond Mars, we're left with a single, unanswerable thought. What if this isn't the first time it's been here? What if we just never noticed before? If this story left you wondering, if you find peace in the strange and comfort in the unknown, consider subscribing for more quiet journeys through the mysteries that keep scientists awake at night and dreamers wide-eyed under the stars.